show on the road. Bam, bam. Bam, 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 bam. Bam, bam. Bam, 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 bam. Bam, 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 bam.
Michio Deming says test.
Yes,
Michael
sir.
says test.
Yes, sir. Come on. Welcome indeed. Welcome back. Welcome back. All right. Welcome back to the stream, everybody. I hope you're having a wonderful day so far. My name is Michael. I'm back teaching myself. Doing another programming session here, like we do. We're going to be back building our project SpectroSim today. I'm really enjoying building the project and adding the features, and it's been a lot of fun so far. So we're going to continue on. I want to get this project done ASAP and at least get out a working, version of it as soon as we can. So yeah, that's the goal here for today. All right. Let's see here. Oh, we did. Ah. All right, what do we need? What do we need? All right, so yesterday, you guys, we made some really good progress on our project. We were able to actually, be able to search these compounds and get failure indications on compounds that don't work, potentially. Maybe not. Oh, our back end isn't running right now. That's why. We gotta run our back end. All right, let's see. You gotta run your back end. Okay, we're here on our back end. Alright, we gotta run our back end here. There we go. Alright, now our back end's running. So now that our back end's working, we are getting responses from our back end, which is really awesome. Such as error compound invalid here. We also can generate real compounds. And it fills in the placeholders on successful responses here for aspirin. We get actually the description populated, the compound ID populated, the compound, the lambda max, and the epsilon max into here, which is really awesome. So that's super cool. I'm really happy we were able to actually do that. Which is really awesome. And so we can do this with a couple of different compounds like benzene, right? We can get benzene, which is 241, benzene with a lambda max of 243 and an epsilon max of 158.49. So it looks really, really awesome. So today, my friends, I think as we're going to, incorporate our plot generation here. So there's a few things we need to add into our actual compound generation.
Starts with 8.5. Why the 8 is big.
Why the 8 is big? What? 8.5.
Mohan says Plodley Bob.
Oh, don't worry about this. This is not the right plot. This is just a dummy plot. I don't have any plot generation going on here right now. All right.
Mohan says graph.
Let's go ahead and jump back into our project here. So, all right. This shouldn't be that bad, I don't think. Our first thing we need to do, let's get some water here. Let's talk this through. So the first thing, our goals for today, you guys. Welcome back. I appreciate you guys for being here. Thank you guys so much.
Mohan says table looks good.
Yeah, the table looks really nice. It has like this highlighting going on, which is cool. All right. So we need to let's push for 2300 today, eh? 2300. Let's push. So today is going to be kind of fun. We need to actually use our Gaussian functions. We love you, Jim.
Mohan says, are we saving search history? Why you decided to use table?
Yeah, my caches are being saved here. Mohan, where you been, bro? You gotta pay attention. All right, so so today is gonna be kind of cool. So what we're gonna do is
Stream until 2300 FR.
yeah. Okay. So what we're gonna do is okay. You guys are distracting me. I gotta get through my thing. I'll have to turn off TT. You guys are good. All right. So what we're gonna do is we need to use our Gaussian distribution function and our generate Gaussian and our generate our absorption right, our absorption values. We're going to need to run those functions and then have those be baked into the compound dictionary and save that within the compound as well. So right in here, right, we're going to have a generated list of x and y values that are going to be preset for these conditions. And so we are going to run those and give those back to us, right? So that's what we're going to do here. So let's just think. So in our main project here, this is where we're working. This is our get function for actually getting the compound, right? Absorption compound. We have the cache where we open up the cache and we save it in there. If it's not in there, we're going to generate a new compound. And then we're going to give it this information. So right here is where we're actually generating, we're getting this compound dict back that's returned by these functions. And then we're actually generating, adding the compound dict into the content. So here, right, we're going to say add Gaussian distribution and what's our other function? So let's go to our compound class. We have Gaussian distribution and absorption. Arrays, value arrays for a compound. Okay, right? So here, we're importing our compound class, so we can actually do this, which is nice. So our compound... Perfect. Perfect. So what we're going to do is we're going to generate a... return the found compound name. Okay, perfect. So then we're going to add onto here. I'm trying to think. Do we want to generate a class? Well, we obviously are going to need to because these are methods. Yeah, so we're going to have to do this. We generate the compound dict here with this information. The thing is I don't really want, should I create a new class object? Is it really necessary to do so? Or should I just... Should I just... Okay. Yeah, so we're gonna have to do it, I guess. So these are our web scrape functions. Sorry guys, I'm trying to think through this. Web scrape functions. Right, and then here is gonna be our... Hey, sorry Douglas. Sorry, I didn't put it back on my TTS. Oh, well, I'm glad you're feeling better. Welcome back, dude. Thank you, Douglas. How's it going? We're building SpectroSim right now, which is pretty cool. This is what we're building. So we're working on our back end here. So let's go ahead and get. See, these are going to be our right. These are going to be our Gaussian distribution functions. We already have a comment. Goofball. Okay, here we go. So let's go ahead and actually. We'll make a pseudocode here. We'll just say create a compound class to access methods. Okay, so we're going to create this compound class. So we're going to say compound is equal to a compound, and we're going to say that the name is equal to compound dict quote name. We're going to say that the this is the lambda max.
What music are we playing, Mike? Mohan says, Mike, have you done any calc while I was gone? I heard you started calc 3.
No, we haven't done any. We've been building our project. I've been wanting to get this out because if we want to start applying to jobs, this project is kind of going to be our icing on the cake, I think. Or icing on the cake. Or icing on the cake, I think, for kind of, I think, cracking that window, maybe. I could be naive, you guys. I could give it a shot and just get completely rejected from everything, which, you know, is what it is. Back to the drawing board, I guess, boys. But this project is going to be like a really nice demonstration of something that we built from scratch, you know, that showcases not only our chemistry knowledge, but like a real full stack development, you know, at least understanding. Now we don't have like user base or anything. That's a little bit kind of that stuff I need to get some more familiar with, but at least for the, you know, get maybe get a shot. We could get a shot. I don't know. So our lambda max is going to equal our compound dict. And we're going to, what is in our compound dict? So let's go to our cashier, lambda max. Right, and then our epsilon max is going to equal to our compound dict. And this is, I think, just epsilon. Yeah, I keep re-changing my names here. Not good code practice, my bad, guys. Uh-oh. Who else does that, where they go back and forth on their variable names? Just even else. It gets shorter and shorter and shorter, to epsilon just becomes ep or e.
Apply to biotech roles. Apply through your current company or Amazon recruiter showing up in chat. Tim says alternatively wait until Mohan becomes a SIA.
If Mahan doesn't burn out first, Mahan's burning out as a freshman. He's burning out. So Sigma, we need to figure out what to do with this. We'll come back to that. Concentration, we also need to figure out what to do with this. We'll come back to that. And then that generates a compound. That's not a bad gig, dude. It's not a bad gig. It's a lot of dough. Woo! Nearly doubled since 2020. Yeah, no crap. You like tripled the price of burgers, bro. This guy's a criminal.
Tim says my dream job is CEO of McDonald's tech department.
Criminal of the American people. For real. Criminal of the American people. Okay. So, right, I'm curious. Let's go to our compound here.
Michael says what resources have you been using to learn Python and React?
Yo, Michael, nice name, dude. How's it going, man? I've been teaching myself Python for like a year now. I need to do like a year update video. I'm like, yo, 1 year. Hopefully, that'll be a good video on the channel. And show, maybe after I finish this project, we'll put that out like 1 year program. These are the projects I built, and yada yada yada. So hopefully by the end of June, we'll put that out, and I think that'll be a good showcase for a wrap up on the year of programming. But I've been started with Harvard CS50P as my first ever introduction. I read Python Crash Course. I've been reading DSA in Python, Fluent Python, Python Machine Learning. I got a Discord link down below with all those resources for you guys. Yeah, so it's been quite the journey.
Apply for Donald's then.
Yeah, for real, Mohan. Okay. So we have a compound here. Now, I want to... The thing is I'm unsure exactly... Well, let's look here. Let's look at our function. We can easily tell by the math, right? So absorbance equals the epsilon times length times concentration data.
Get rejected as fry cook.
Light length. I call generate epsilon. Okay, so then in my main here, this is what I was doing it. Here, I'm gonna take this. I'm not gonna use it here. And I'm going to put this here. And I'm going to take this. I'm going to put this here. So I can show you guys my function. So okay, so we're going to say with open, we're going to open cache, compound cache, .json in read mode. We're going to load right. And then we need to set a wavelengths. So let's go to our globals here. This is where we need wavelengths. Oh, import all here. I made the global, so I'm comfortable doing that. Okay. So then now we have wavelengths here. So now I can show you guys actually what this looks like. Oh no. Classes. This is in compound. From is it /globals like no so we have this is in our classes, so we need to go out of class. How do you do it? I forgot. So for inside classes, fine, we'll just go I think backend.globals. Globals is in backend. I think .globals. That doesn't work. I forgot. Backslash dot backslash dot globals. No, it's a parent package. Dot? No. Anybody know? Let's just go SpectroSim. From backend import. I thought I did this. See, if I did this, I could do it. Right, get wavelengths. But module not found. Alright. I want to see here. Let me show you that. .globals. Thought I tried that. What's going on here? You don't even know. I'm in SpectroSim. Huh. Backend.globals. back end. I'm getting this. Oh my gosh. I think someone's clearing a script directly from file path. To make from backend.global's import wavelengths work, run this from project root. Whatever, hold on. What am I? This is my globals. Just this. Okay, I'm gonna actually delete this. I'm gonna throw this as a generated thing here. Right. So now I'm not going to worry about this crap. Okay, so now dang it. With open compound cache. So let me go. Let me cd backend here. Now let me run this. String indices must be integers, not str. Oh, this is a list. I'm gonna do test comp dot wavelengths here, and then I'm doing all this just to show you guys the curve here on Python, but we're gonna do it on JavaScript here. Well, we need this actually, so it doesn't really matter. We have to do this, fix it. So we need, because we're generating the data here and then sending it out. Compound for row and file compound. This is I'm gonna go print file content here. Which is a dictionary. Dictionaries. Compound name equals row. No. I'm gonna say for comp for every compound for key, right? Key value in file content dot items. We're going to say that the compound name is equal to, we're going to generate a compound off the value here and append that compound. We give it a set concentration. So now if I go here and I go, let's go print compounds, and then we'll run this. Key or epsilon max. This is epsilon. Sigma. They don't have a sigma value. Good. So we're also going to remove. So we have name, lambda max, and epsilon. So we're going to remove this. And then I guess we'll set test comp.
DevGood 2020 says, be me, eat a lot of candy, get tummy ache, go catch up on missed league dailies, and it's league code candy problem week. Well,
Test comp dot sigma is equal to, what did I have as before? Like 20? I can't remember. Okay. You have to give a sigma. Okay, we got the absorption curve of aspirin here. Now if I quit this and I give here, we should get benzoic acid now. Benzoic acid. Oh, it's just really close. That's why it looks so similar. I was like, dang, that's really close. I was like, is that really the same curve? That's so crazy. Okay, this one goes up to 120. Right? Whereas
DevGood
aspirin.
2020 says, benzene is a colorless liquid with a sweet odor. Does that mean it's safe to taste test?
So with a sweet odor, I don't know. Definitely not a taste test. And this one goes up to 12. It's a way less absorption. Oh, nice. Okay. Woo! Okay, nice. So now we're getting our compounds. So if I go 3 here, which one are we going to get? Ooh, caffeine is also around 200. What? 243, 227. All these are like so close together for the lambda max. Really? No way.
Mohan says, can you compare the plots?
Spectral information.
DevGood 2020 says, looks like Nylard levels of chemicals. Mohan says in a single plot I mean.
Yeah, 275 nanometers, 229, 277 in this one. So it's about, yeah, aspirin,
Says
275.
compound in one plot.
Pick up benzoic acid. Make sure we're scraping this right. I think we are. Spectral information. 227. This one is in Sattler's ref is 779 with Prism IR and IR spectroscopy. Not absorption though. This is IR. IR. infrared spectroscopy. UV 252. Nice. All right, so yeah, we're getting our curves now. So now we need to figure out like an appropriate universal sigma and an appropriate universal concentration to, or we could have that be depicted. We could have the user give us those values because, well, actually, did they give us the concentration? Let's look.
Big for caffeine? Mohan says compare to others.
It's just the way that the data turns out. Just the type of compound. Okay, so spectral information. Right, so if we say log 311 here, so this is, does it give us a comp 1%?
Mohan says, I wanted the science behind it, but it will be a lecture to explain NVM lol.
So ether it doesn't give us a concentration though. So I'm gonna say here. I'm gonna say here. I'm gonna go to my almighty orb here. I'm gonna say, this is my scrap from. Yo, what's up, Nugs? I do not get a sigma concentration of the ether solution. Concentration in ether.
Tim says next project. Deming G.
I do not get a sigma concentration in ether. So I am needing to come up with some universal standards for these, or allow users to customize them themselves. But then the data wouldn't be super accurate to the reference. You got a common crossroads in spectroscopic modeling, balancing realistic defaults with user configurability, especially when key parameters like sigma or concentration are missing from source data like PubChem. Let's break this down. Right, so this one, lambda max of aspirin. Right, we're computing that right. 10 to the power of 3.11, which is about 1300. I think ours is more exact because we're using NumPy to compute it. Yeah. No, that's the wrong function. Where is it? It's in our web scrape, I'm sorry. Our web scrape is here. We're doing this. 10 to the power of the float of the match, right? Really? $12.88.
Debka 2020 says, actually random shower thought, is there any chemistry stuff that teaches you daily problem style? Debka
I'm not sure.
2020 says like puzzle websites of problems.
I'm sure there are some. Why? How did he get this value? 10 to the power of 3.11. It's not that. Well, you're missing standard deviation, the Gaussian curve, Brown abandoning, concentration, path length. Assumed at 1 centimeters in standard cuvettes. These are common standards in spectroscopy and serve as defaults. Broad enough to model realistic peaks but not overly wide. Literature values for organic chromospheres often vary in this range. Concentration, common for dilute solutions, moles per liter. Okay, so then in the compound here, if I give a concentration in Python, can you say E? Yes.
Cooper X says, shoot the front end.
Show the front end. Show it now. All right. Here's the front end. This is the front end here, sir. We're able to get compounds. Let's get aspirin. No. Oh, we broke our main function, that's why. Let's try again. No, it's broken. What are we getting?
Doubtless Dark says that E. Do you mean an octal number?
No, scientific notation. What's going on here? Oh, here are my compounds. It's generating a bunch of them. Hold up. Why isn't it working? What's going on here? No! What did I do? Did my backend turn off? Invalid syntax. No!
Douglas Dark says cuz that's what Python will understand it as, I think.
Oh, we have to give it a concentration on initialization too. Well, by default, it's none though. Am I trolling? What's going on? Oh, my backend just turned off. That's why.
IDK Python, but it looked like it crashed from earlier.
Yeah, my backend turned off. Come on. There we go. No! App already in use.
Nut says oh. Nut says lol.
There we go. Why are we generating plots? What's my backend doing? What's going on?
Nut says says I thought that was your backend. Wasn't really following. DevGood 2020
Oh.
says is SpectroSim online, or is it still just localhost prototype?
Yeah, not online yet. Not online yet. Holy cow. What's going on here? Oh, I think it was generating compounds which had that plot function in it. I don't know. We'll see. Alright, I'm not sure what the heck was happening. Okay.
It says oh it was your backend lol.
Okay. Why is it generating plots on my back end loading? What is going on?
Nut says, LOL it's definitely crashing.
Why is my back end generating plots right now? This is not in my class. What? I'm so confused. What is going on? Starter or loader?
Cooper X says, thoughts on ChatGPT for code? Nut says at the end. Nut says yeah right there.
Pause. Pause.
Nut says line 66.
Yeah, but why? My main function though isn't creating a compound. I don't get it. Why is this doing that? What is going on? And then it's printing out. Oh, now I'm getting stuff.
Import a Python file.
Yeah, it does, but I'm not using it yet. Oh, this all comment. What is this plot generation? I'm so good. Why is our server calling matplotlib?
Nut says maybe Python runs the code anyway, it's outside the definition of the class.
Yeah, maybe. Let's try it. Yeah, look at that. So I guess if you import the class, it runs the class. If you run the server. So if you have code like test functions or things that are accidentally in here on lines, it'll get ran. Interesting. Okay, so if you just make sure to comment out your test. Okay, so now you can see my front end here. This is what it looks like by default. Right, and then you can put in test, search, error, compound. Oh, I spelled that wrong. No! Come on. It was late last night, you guys. Come on, don't blame me. Search status. So we gotta go to our front end here. Ah, crap. No, this is gonna be.
Not sure how Python works, but I thought it would be a bit like JS.
Compound invalid. Okay. So now if we refresh this and do test, search, error, compound not found, / invalid. All right, that looks pretty good. But now if we go aspirin, search, success, and aspirin gets loaded in with its description and its information here from our database. Nice. Okay, so now what we're gonna do is let's get back to what we were doing before here, before we got distracted. Okay. So in our main function here, we're creating a compound class to access the methods. Right? So we're going to create a compound class, but we need to preset a concentration and a sigma. Let me go back real quick. So I want to go here. Let me open this up real quick, and then let me run some tests here. Okay, so now we're getting caffeine here. So this concentration shows if it's a lot smaller. So what if I make this like double those, like really small, and then exit out of the plot. Okay, now it just makes these way smaller. If I go back, I generate a plot here. Okay, now it puts those at bay. So if I generate a random sigma, let's put it like at, now what is a 10 sigma due to the width of the curve? Right, this is going to alter the width. So now you get just a really high peak at that wavelength. So should we split the difference and hard code it into 15? Or what we could even do is we could, what do you guys think about making a random number between 10 and 20? Because those are the typical ranges of width of the curve. So it could look a little bit different each time, or do you think having it, if it's coming from sourced data, having it just be uniform with a hard-coded number of an average of like 15 like this, do you think, or a range of 10 to 15 with a random number? What do you guys think? Let me grab a refill on my drink here. I'll be right back. Let me know what you think. I got my headphones and I can hear you.
Nut says Nut says I'm not really sure what you're trying to do, lol.
We got the kitty mug today. Got the kitty mug. All right. Back to work here. Back to work. So if I generate, let's do 5. We're gonna get. Oh, no index there. Let's see for. Ooh, 2, 3. Ah, caffeine. All right. Whoa, caffeine's gonna. Oh, that's a CID. Okay.
Tim says no days off in the Deming household.
No days off. Let's go. Okay. So we're hard coding in a sigma of 15 here. So this is okay. So it said a concentration ranges are typically between because also we're giving a path length in our here as well, light length, which we are coding in as 1. Here. Okay. Let's say light. This is the distance of cuvette light source. Typically 1 centimeter. Light length. Okay. So now what we can do here, let's go ahead and comment this out. Let's get to work. Okay, so we're going to generate a, given the compound sent back to us, right, we're going to generate a compound and we're going to give it a sigma of 15. Right, and we're going to give a concentration of 1.0. And then, so if we go here to, let's just get out of here. Here, I bring this over.
Overnight Nitifax 65 centimeter says, cheap viewers on streamboo.com. Remove the space.
that says. That sounded strange. Okay. So we filling that, we're filling that, we're filling that, we're filling that, we're filling that. So we need to run these two functions given self.wavelengths. So I'm generating 1,000 here. What if I generate 501? But I had to skip. No, we wanted 1,000. That's why I did 1,000. All right, we did 1,000, so we're capturing. But I'm gonna skip every 30 rather this time around. So now I want to uncomment this out and see what it looks like when it runs here. Give me a plot. Give me a plot. Oh, just chop it, chop it, chop it, chop it, chop it. So if I say, give me 1,000, but we skip every 5, what does my plot look like now? Not terrible. It's got a little bit sharp peak here. If I say 6, do we really start throwing a loop here? Yeah, we start getting jagged up at that top peak. So that's why I think I remember doing this before and coming to a decision on 3 in terms of the best space saved as well as the smoothest curve for the least amount of points generated, or most amount of points generated for the smoothest curve was around 3 points per 1,000, or every 3 points in 1,000. Okay. My headphones died, guys. Sorry. My bad, my bad. Okay. So now we can right. So this is what I do. I'm gonna create a compound here. So if I say, let me write a function here for this, right? Let me say, let me define, let me override the dict call. Which is an at property. Right? Is the
Nug says what is absorption spectroscopy used for?
what is it used for? um, like generating like you can do like antibiotic stuff or like medicinal stuff with it, or like material type of things, or lots of different stuff. Good question.
Tim says my ears just exploded, bro.
Sorry. That property was a built-in attribute of it. Okay.
Nug says LMAO.
Okay, that'll be easy then. We don't have to do this. We can do this then. So we can easily write it back as this, which is easy. Okay. Okay, so then we can write. So now we're going to do this. Now we're going to call compound dot generate Gaussian distribution given compound dot wavelengths as our wavelengths list, and then we're going to call compound dot generate absorption, right? And that doesn't take in anything, or it takes an epsilon and light to float. Epsilon's list. Okay, so I had to pass in. Okay, so this gives compound dot generated epsilons and compound dot light we'll say 1.0. Epsilons equals to epsilons and light length for generate absorption. No, generate absorption. That's why I wasn't getting those back before. Good. Dot generated absorption, epsilons. So now what we can do is call compound dict compound dict we're going to override this as the compound dot dict object, right? And then we save it as this. From web scrape with Gaussian. Okay, so now we have that. Info. So we call this. Now, does this have a method at the end?
Nud says it shouldn't be the other way around.
Yeah, it might be. Hold on. Forgot. Mol.dict. No. Print mol.dict. Yeah, okay. Okay, so we're going to overwrite the current this compound dict with this new compound, right, that has all of this information here. Compound name. We're getting all that information, all three of those informations, and loading them into here. But we're losing out on the CCID and stuff. Oh. So then can I combine?
Nud says ONVM.
Can I combine? Oh, let me open up my Fluent Python. Fluent Python map I literally flipped right to the page. Map mergings. Python supports we can go like this. Boom. So now I print dict here. Okay. Now if I go refresh, aspirin search, my back end, okay, generated aspirin. Print compound dick. Is this working? Oh, this is just returning up. So we have to do this. Delete. We have to restart, delete our database. Right, and then test. Search. I go.
Joe says, happy to see you prefer the real books, not PDF.
I read the PDFs on the stream so you guys can follow along, but I have the real books here too. Yeah. But yeah, that was a quick little reference into the book. That was fun. So let's see if that worked though. Okay, here we go. Oh boy. That's gonna be a lot of data. Oh god.
Tim says, when are we learning algorithms, Mike?
Have we not been? We've been doing leak code. We've been reading DSA. What do you mean? What do you mean? Okay, now we're getting data for aspirin here. Okay. So now we're generating data no matter what on a search. Now let's call.
Nug says, lol.
Does this not keep everything? Oh, it did. Good. Our merge worked. We merged our two dictionaries together successfully. So now what we can do is so now we're getting the data and we're sending that back here. So if I were to console.log this in my front end, you would see in my log here that it got the data served to it. So hold on. Let me go to AbsorbSim here. Going to compound data here. We're going to console.log compound data here. So if I search this spect console, here's all our objects and there's all our wavelengths. Haha! Nice. Nice. That's really good. Okay. All right. So we're getting a compound. So if I look up a compound, let's look up benzene. Hey, we got benzene. With all of its data points. So now we can start, we're getting the data points, we can plot here. We now officially can plot. Okay, let's see here. So on our AbsorbSim page, we have a plot here. AbsorbSim plot that we're generating. Right here. So the data, this is, okay, so I'm going to send in props here, right? And so this is going to be JavaScript props dot x data. I'm going to say props dot y data. Type going to be line.
Tim says grad level analysis of algorithms with lots of math, Mike.
Scratch my head. What kind of books does that entail? Is that something I have to get? I haven't even got through some of the other books we have to read. I'm project man. Projects are kicking my buns here. Okay, let's look up different types of modes for Plotly.js plots. Different types of modes for Plotly.js plots. Type, scatter, lines, markers, text. Connect data points with lines only. Text won't show unless you provide a text array. Oh. So scatter lines and markers. So let me go to our here, and let's pass in.
Nug says side quest. Implement your own plotter.
So if we have.
Badu says bro WHT kind of project is this?
How's it going, dude? Welcome back. I appreciate you being here. Let's get some tunes going again. All right. Okay. So let's do. This is going to be set compound x data, set compound y data.
Tim says MR Sexy's AirPod Pros real are plugged in.
Compound dot. We're serving the compound dot generated epsilons is our x data, and generated absorption is our y data.
Austin says, hi.
Hey Austin, dude, how's it going, man? Expected. Expected, comma. Line 13, lines and markers. Comma. I'm gonna give it my plot here. See how it likes it. I'm curious. I'm trying to learn Plotly. Yeah, it looks good, but it's one syntax with X and Y assignments. When you're embedding dynamic values inside object letters, you don't need to curly braces again. Oh, so I can just say props. I can just say props? Ah, okay. Okay, so now... What is this? Huh, what is that? Let's see. Well, it's just a secondary plot. I don't want a secondary plot. I don't need that. Okay, so if I type in aspirin here, okay, so hold on. Okay, hold on. We might almost be there. Hold on. Okay, we're trying to generate this plot here. So if I go absorption page, we got set epsilons and set xcomp data is not defined.
Nut says looks like something wrong with AbsorbSim JSX.
Yeah. Generated epsilons.
Nut says, did you define the new state variables?
Oh, you're right. Thank you so much. I appreciate you. Yes, they're not defined. Thank you. So here, set y data, comp x data. Was that the song? Or is that my drink?
Nut says, got you. Nut says, then make sure to pass them as props.
Huh.
Nut says, unless it's done automatically somehow.
Yeah, I'm passing them as props in the graph here. Props, x data props, and then absorption I'm passing props into the graph here. Then we'll pass them into here. So into here we'll have to add right, so this is going to be generated absorption equals to, and then generated epsilons is equal to, and then we're going to do compound x data, compound y data. No.
Bot Do says Dudim Nubian field, can you explain what are you doing? I mean, what kind of project?
Yeah, no worries. Just hold on one sec. Let's just finish my train of thought here, and then I'll help you out one sec. Let's just finish this train of thought, and we'll get you guys caught up on what we're doing here. Want to make sure you guys are following. Oh gosh, where'd I go? Okay. So now we're setting that. So now we'll go back up here. Let's finish this part. So default value is not NA. We're gonna have the default value just be 0.
Nut says I think it should be comp y data equals comp y data. No?
Well, this is what I'm passing into the plot. So my plot is expecting props of x data. Oh yeah, x data, y data. My bad. This is going to be y data. X data. Why is it suggesting comp? We have these two here, we're setting them to 0. Right, it needs to be a list by default. Comp y data.
Nut says or yeah that. Nut says prop name equals prop value.
Yeah, prop name equal prop value. Okay, so now if we pass in aspirin and search,
Nut says nice.
okay, we're getting a graph, but that's not the right graph. Let's zoom out.
Nut says not exactly what we expected, but it's something.
It's something, right? Okay, so why is it not? So absorption plot is getting props.x data, props.y data. Well, this is just, so it's definitely distributed, right? Oh, our y data is not coming in appropriately. Oh, we're saving them at the same values. That's linear. Okay, so something's not being saved right here.
Joe says, it seems that you're very passionate about this project.
Yeah, it's pretty fun building it so far. It's got a lot of really cool features. You know, we're fetching APIs, we're scraping web responses, we're, you know, have a whole front end established, sending our own server requests ourselves, generating custom plots. Like, this is a huge project that I think would really, you know, open the door for us to, you know, get employment in as a developer. So this project I think is going to be kind of crucial for us to move forward. Okay, so then hopefully I could eat my words, right? Eat crap. Okay, so our plots aren't being saved appropriately, it looks like.
Nug says when we logged them earlier, were they right or no?
Yeah, they were right. So if I can show you here, look. Let's take this, uncomment the testing. This will generate plots now. Maybe. There we go. So it's generating, my functions are generating y values appropriately, but I'm not saving them into the right places, it looks like. So add a Gaussian distribution for the arrays. We're generating Gaussian distribution given the wavelengths.
Nug says not the plot, but the logs of the x and y data, just making sure that Python is generating exactly what we want.
Well, this plot here is where these functions are coming from. So by that plot being correct, these functions are correct. So I'm not saving them though appropriately.
Nug says we can narrow down, it's more of an issue of how we're passing it back.
Yeah, exactly. Okay, so generate distribution, we're giving the compound wavelengths is what we're generating the distribution across, which is our original x values. We're scaling those to be a Gaussian distribution. We are then generating absorption given those x values, and then we in a 1 centimeter wavelength, or light length, sorry. We merge the dictionaries together. Here's where I'm printing compound dict. I'm going to print compound dict. I'm going to index into, I'm going to grab compound dict rated epsilons. And then I'm going to grab all the first 10 of them.
NPY edit says, hey, how is it going?
It's going good, dude. How's it going? So why am I not getting a print? Here. So if I do ask for a search. Oh, because it's already in my log. Okay, so then let's go here and go. Oh, then let's check my log. That's where it's at. I can easily check it
Says
there.
I forget. Are you always generating that data with the compound class or only if the cache has
Just 7.6. Okay, so these are being saved as the same values. Why? I think it might be this.
It says so. I didn't saw your previous lib, so could you once tell me what you updated?
Print compound dict. Yeah, we are trying to do the plot now. We're working on the plot. We've updated our functions to actually generate plots and save them onto that compound object that we're saving in our cache. And now we're uploading those back to the server. We've created some state objects to save that information as X and Y data. And we're trying to generate the plot, but currently we're not getting, I think it's this part right here. Because these functions should be doing what they're supposed to. So I'm gonna say this, for key value in compound dot items, we're going to say compound dict, which is that object that was returned back to us from our web scraper. Let me go really quickly and comment out this guy, Hitha. So the compound dict will access that key, and we'll set this equal to that value. So that'll append all the values into compound keys and values into compound dict that are unique and override, but it shouldn't override, it should also, right, it should keep everything. So now this isn't printing for some reason, so I'm not sure why. So now if I delete my cache, I refresh my server here, I type in aspirin, I search, test comp is not defined. Oh, here, oops.
Nut says, wait, what are lines 61 and 62 actually doing?
These are generating X and Y values and saving them into the object. So this has X values associated on its wavelength. This scales the X values according to a Gaussian distribution and then saves those as a instance variable on the object compound. And then this does that for the Y values using the Beer's law, which is absorption based on those X values. So now can we say search? Failed to fetch, been blocked.
NPY edit says so. Now the graph is working right.
No, compound attribute error. No. Why are those the same values? 622, 7622? Yeah. Doesn't make any sense. No, so it wasn't that. Ah, crap.
Nut says, have you logged the outputs of compound gen?
That's what we're about to do here.
Nut says, why don't you just directly add them as key values into the dictionary?
That's what this does. right? It does, but for some reason it's duplicating these values. So print generated epsilons here. Seven, 6, 2, 2. Okay. Now let me take this statement, put it down here, and let me say print generated absorption. And let me delete this. Seven, 6, 2, 2. Make any sense? Okay, so these values. Look at our compound class here. So when I call generated Gaussian, I give wavelengths, generated epsilons, and light lengths. Why are these values coming out to be the same list of values? Oh, because you have epsilon and epsilon max here. Ooh. Okay. So let me go to my web scraper. That might be it right there. So my web scraper, I need to change where I'm this grouping, I'm saving this as epsilon max to match my right. So now if I delete here, transfer failed, 500 failed to fetch handle compound search. Of course. Oh, key error epsilon max. Right, and then you merge the compounds together. So now if I refresh, aspirin search. Dang it. 7.622. 7.622. Why is that generating the same absorption? That makes no sense. Dude, I'm lost because I'm using the same functions in this other script right here. I'm using the same functions. Oh, I'm so dumb. You don't plot the epsilons, you plot the wavelengths, ding dong. My graph is off. That would have been a clear tell.
Says
Bruh is right. Human error. Okay. We did have that one error though that we ended up fixing now that we saw that with that epsilon. So let's go back into our main program here. And we want to generate absorption. We don't plot off of the
Riddle says, "Hey Mike, good evening buddy. Nut says I still don't get why they're the same values.
Yeah, me either. So we generate the distribution. So the distribution function generates an epsilon.
Gotta go, is midnight in here.
Appends a list of epsilons. Oh, I don't think they're the same. I think they're just very small and they're different. They're just factored by by 1 here, and then a really small value, and then 1 here. They're just factored by a really small value of concentration. Okay, so that's why they aren't the same. They're slightly different. But so this is 1021E. I guess I'm trolling. No, that's 34. Interesting. Okay, so then let's just save then what we're sending back in terms of the y values. So on our front end, so on our absorption plot here, we need to pass in, this is set y data is not generated, or x data is not generated epsilons. This is going to be what are we sending back? We're sending back wave, I think it's wave length, like this. So now if I say aspirin search. Woo! Yeah! Let's go! We got the plots! All right. getting plots. Look at that. Woo! That looks awesome. That looks awesome. We just need to now just polish it up and make it look cool. Yeah. Let's go, caffeine. Oh, okay, so we do need to link it up to this, right? The button before we generate.
Nug says nice.
Or we could just remove this button altogether and just have it be like that. Or do you guys like having the option to generate it before, or have it just do it automatically? This button, so it was supposed to load and then generate to save myself some space. Oh, this didn't load that. Hold on, let me delete this. Where'd my epsilon oh, I need to change this to epsilon max. There we go. Yes, sir. Look at that. All right, let's dial this plot up, yeah? Okay, lines and markers. I'm just gonna say lines. There we go. X of like 91. 275. Whoa, this is wrong. What? Where'd all my wavelengths go? Yeah, look at all these. Why is it not plotting all of these? What's it plotting on?
Riddle says, have you worked on the search status error?
Yeah. We fixed that part already. Why are my Y values, or my X values, all not showing up here? What? I'm so confused. Oh no. Compound has wave lengths. Y data. So the X data is wavelengths, that's why. There we go.
Riddle says, what are the other modes available in plot component?
In plot component, this guy here? I don't know, we're trying to figure that out here. Oh, modes? I don't know. I asked the AI that, and There's like bar, I think, or that's type bar. There's like marker and plus lines. Okay, color. So marker color. Okay, let's have this be so I wonder, can I set, if I have style here equal to
Brittle says I see.
what if I say class name width 100 or width full, height full, and I delete this style. Okay, it's still working. So now can I give border like 2? Let me look up plotly.js plot styles with React.
Brittle says, I'd say match graph color with the theme color. Yours was cyan 400 if I'm not wrong.
With tailwind. Let me look up here. Let me go. Can you style plots with tailwind? You can't style length and lines. Okay, here's like a bunch of options I have. Okay. Okay. So let's go back here. You can't use tailwind class name directly here, so we have to use these styles, which is fine. So this is layout here, title. So this is going to be props dot title, right? And then this is song. Yeah. Layout, this is all within the layout. Okay.
SS cache.
So then the configs, the layout. Auto size true. So layout gets 2 things. Like so, and then down. So then you can just do these down, make it easy. Layout. No. this. That's not here. Like so, okay. So now this, we go back onto here. Text, or title. You open it up. Props.title. And you can give font. Family. Roboto. Size 20. Okay, so that's the title. So I go back to my plot here. So props.title. Aspirin. So let me pass in here into my plot. Here, X data. Title equals to compound name. Like so. And aspirin search. Aspirin right there. So I give Roboto. There we go. So the title is going to be aspirin UV. Do I have to go like this? This. No, not like that. It's not JavaScript. Props.title. Let's say hello here. Props.title. Single quotes. Oh, yeah.
Brittle says it is JavaScript.
No, the props is in JavaScript. Let's say,
Brittle says you can use the backticks.
oh, to add spacing, yeah, probably. Aspirin version. How do you give a new line in string JavaScript? Backslash in. Okay, let's backslash it. Maybe not.
Riddle says it didn't work cause it's $, and you typed $.
Oh, gotcha. Trying to put this on a new line. The absorption below it. Maybe a spectroscopy. Roboto says 25. 22. Need to increase the size of this. Okay, so let's keep going on some styling here. So I want okay, so I'm going to do, so in my layout, I'm going to apply a,
Raphael says n equals new line.
forward slash, backslash, forward slash. No, I think it's because of I think it's just because of this title thing. Okay. So we got here. We're going to do inside of our layout. We're going to apply a plot BG color of right. I'm going to do RGB A 0, 0, 0, 0. Do you have to have single ticks? No. I think so. So then if I do paper as well.
Riddle says I personally like hex codes more than RGBA values.
So if I give this What? Am I trolling? Do I have something wrong here? Ah, here we go. Haha, look at that. That's pretty cool. No, that looks dumb. Okay, so let's think here. How do we
I
make
think
this?
you should make paper BG the color of the buttons and the curve the color of your website's BG.
Paper background colors. So I make this. Wait. This. White. Huh. Why does the plot BG color in transparent mess with my x-axis? That's weird. Why does changing the color here of the background impact my... Well, that didn't do it. That does it. Now it's there. Was it just a glitch? Oh yeah, it was just a glitch. A visual glitch, I guess. Nice. Look at font color. I'm gonna go to my layout here. What is that
Myrtle
hex?
says plot is the region within the axes. End of point says, oh, can you explain why too much zinc can affect the spinal cord? Myrtle says paper is the whole graph, including the axes and its values and even the values.
Yeah.
End of point says some article on CNBC mentioned it and no biochemist. Myrtle says I mean even the margins.
Even the margins. Isn't zinc just bad for like neurons, like in general in excess or something like that? Based on a quick look up here. Alright, let's keep building here. 1 second, you guys. Let me check my thing here. Check my thing here. Okay, let's keep moving. Okay, so why didn't that?
Riddle says, I'm sorry, I have split the message into multiple ones. Tirafanail says, try to plot all attributes on the same chart, each attribute different, call it as a practice. Tirafanail says
What?
color.
What are you talking about, dude? This is what we wanted. Where you been all stream? We've been trying to plot this all stream. Chill. What are you talking about? Plot everything. This is this. What are you talking about, bro? Okay, let's keep moving. So marker color here, I'm gonna make it my hex color of this guy, which is. So let's go to our AbsorbSim. Text cyan 500 hex. What's the hex code of this? Hashtag 6B. Okay. There we go. That looks sweet. Okay. And then we give a is it color? So let me say marker colored lines. So is this color right here that I added here, is this doing it for the lines? No. What is this color doing? Nothing. I'm going to take this color out and apply it to here. That's data. No, I want title. Yeah, I want title, color title. Font. Oh, do I have to do color inside of the font here? Ah, there you go. Okay, so now we'll say X axis. We'll open up. Oh no, not X axes. X.
Riddle says check if there are any props to adjust so that the text colors, including the title and the values on the axes, to some color. I'd say cyan 500 itself.
Let me do this. Const. How do we do this in return? No. Const line color equals to this. Okay. And then we'll say const text color is going to equal to this string. Because I'm anal, I'm going to change this. Okay. Now we need to set our x-axis labels. Okay, so we'll say within here we'll say x-axis. So if I say show grid, I set this to false. That'll remove the grid on the X, and then I come down here. Let me take this, copy this down, call Y-axis. False. Now if I type aspirin search, no, that's what you get. I'll say true here. And I'll say true here. There we go. Now I'm gonna say the color is gonna be really faint, right? So line grid color. So we'll put, this will be grid color. So let me make the grid color then be, do we have a dark gray? This is a little bit gray. Can I get a color charter so I can pick one? No. Let's try this guy here. And then I'll set this one also for the Y. There we go. That looks good. Aspirin search. Boom. Now if I say X-axis text font, color. If I say text color, okay, yep, that's for the values of the text. There we go. There we go. Oh, that made the X-axis color. How can you set the X tickers? Tick font. So you go X-axis, then you go tick color, text color. No, that's not the ticks. We don't want that. Tick font. Color. Text color. There we go. There we go. Nice. Now aspirin. Boom. Oh, that looks awesome. We're cooking, boys. Let's go. That looks great. I think that looks really good. Now I could give it a background. You guys like the transparent background? Or should I give it a...
The point says don't forget the X.
Oh,
labels.
you're right. You guys like the transparent, or should I give it a background of like this dark shade or this light gray shade?
Point says looks good.
Like this dark gray with some like a.
Point says try the dark gray.
Okay, so let's go to our absorb sim. We've got our this guy, Slate 700.
Myrtle says, I think light gray in the table should look nice.
Light gray in the table? Okay, we'll try both. We'll try both. Okay, so on a hover, Slate 500.
Myrtle says try both. Myrtle says yeah.
Okay, so this color is on this table data row. The row for the header is Slate 700. Oh, that's the dark gray. We want the light gray, which is Slate. What's this guy? What is going on here? So this has CID.
Myrtle says Slate 500.
Oh, here. Slate 600 is the dark one. So it is Slate 500. Table body, table row, Slate 800. On a hover. Slate 700 on a non. We could try some different ones. So let's do Slate, that's border. Slate 200 is the text. I don't get it. What is this gray color? Slate 600 for the table. Okay, that's it right there. Okay, so that's the hex. So we'll go to our plot. We'll add in a. We'll go here. Const table color is this guy. So we'll go here. Plot background color. Table color. Maybe a little darker than that one. So we want the Slate 800 then. It's this guy. Yeah, that looks pretty good.
Myrtle says try rounded vertices and BG shadow as well.
Yeah, we'll add that too here. So paper background, so layout. Plotly. Huh. This is where my plot is, which is in this div. So if I give a rounded 2XL, if I give a pad of 4, that'll pad it, which I don't want.
Brittle says, maybe a change in shadow size on hover too. It will give it a lifting look. Add these styling, I mean the rounded vertices and shadows onto the plot component itself.
Yeah, it doesn't work like that. Okay, so we can enforce clipping though on the outer div. So we can give rounded XL here. We can give overflow clip. There we go. Now we forced. If I say hidden, that does the same thing. Does overflow clip.
Brittle says you mean adding tailwind classes on plot component does not work?
No, at least I not in this current setup. So rounded. Okay, so then let's take my current. What's my current rounding on some of these components? So I'm doing. Let's go to my. How much am I rounding the edge of this thing by? Let's go to AbsorbSim. Here. Rounded large, and then this is my shadow. I'm going to take this shadow, I want to keep it, apply AbsorbSim, rounded, we'll just say large, and then we want to say shadow like this. There we go. Nice. That looks so cool. So I'm gonna add a. I wonder if we can add a hover.
Brittle says change shadow size on hover.
Yeah, we're gonna have to do hover. Like a hover effect here. I'm asking, can you add hover effects directly to plots? Tooltips, hover, styling, wrap the entire plot easy to find. Data layout responsive and on hover. Okay, so then we'll say in our plot here, you can add inside of here these parameters on hover. Oh no, so you say use resize handler. I'm already calling that. Layout, style, config. Oh, I'm in layout, that's why. Okay, so then here we're going to go on hover. We're going to write a function saying handle the hover, and then handle unhover, and then on unhover, right? So we need to find these. So we'll go const, or we need to add a I wonder if you can apply a hover effect to the what's the handle hover? So handle hover be const handle hover, which is going to be equal to a function, right, where we use an arrow Okay, so we're gonna have a event handler for this. We need to have a variable, right? So const, we're importing React. We need to import use state from React. So const hover color handle hover. All right, we're equal to a use state. Where default will be
Jandir says how's the project going?
How's it going, dude? This will be table color by default. Okay, and then here on handle hover, we're going to set just
Myrtle says, can't we use Tailwind's hover class?
I'm using Plotly, so no. I don't think so. On hover. Okay, so on hover color is going to be set to, let's just make it something crazy, right? Like, let's just set it to the line color for now. And then let's do handle unhover. And this will be set back to the default. So then here, And then here, handle hover. So this is going to be hover color. Hover color. No. I have a default color. On hover, it changes to no, that's not it.
Nux says on hover and on unhover aren't real events. Myrtle says, oh I got it. Why these classes won't work with Plotly. It's because it renders its graphs using SVG and canvas elements.
So handle hover. We handle unhover. On hover. Hover color by default. Huh. Background color, hover Plotly. So it's suggesting us to keep it as transparent at the start then. So
Nux says use on mouse enter, on mouse exit.
on hover. Maybe the hover's for the line. Huh. Okay, so then let me remove these hover effects because I actually don't think I need them applied here
Nux
because
says
my
OIDK
div is
plot has
transparent.
its own events. Nux says maybe it does.
Yeah, it does. Those are definitely events that Plotly uses. Right, you can give them here on hover. See? But we're going to scrap that. We're going to go back here. We're going to go to our div here because we'll use a transparent. And then we'll say hover. We'll say on hover. We're going to whoops. On hover, we're going to do BG slate 600. We'll set slate 800, hover. So now if I say it's a little bit too light. Let's say 700. There we go. Well, then we have kind of a difference here because we're doing hover slate 500 here. So if I say, if I put 700 here, it's way darker than the rest. I say border slate 800. Yeah, I'm not sure what this is doing. I don't think it's doing anything. Oh, it's border. My bad. Okay, so let's give border slate 900 to this guy as well. Wait, we have border slate 700. So I'm gonna come here and give this to, there we go. A little bit of a cool, nice little border there. So we're doing background text 600 for the table. So let me make this then background slate 600. No, that's this line here. So then we'll hover at 600, and then we'll have the border be the same as this guy, which is, or the background code, which is slate 800. So that's the same color. And so now, should we make this font color be blue to match this? Or I think it looks clean like that. So now I wonder if we can go back to here. Can we give a hover effect? On hover, we're gonna run hover color. On unhover. Give hover color, and then here, so hover color, handle hover, and then we'll say const handle hover, which equals to a function, no input, that becomes this, and we say set this is cyan 300. unhover. Set hover color to unhover. We're gonna go back to the default. Align color. So then we're gonna go here. And we're gonna go marker mode. Marker 9. Hey! Kitty, stop.
Myrtle says, I was AFK. How's progress on adding hover effects?
Going good, going good. Hover color. What if I make this hover color to like red? I can't tell if that's getting lighter.
Update the on hover value.
Update the on hover value. Let's see here. Aha! Look at that. Okay, so now. Woohoo! That looks sweet. Okay, we just need to change those colors now. So now we'll use our lighter color of Cyan 300, which is this guy. Nice, look at that. Now I just need to tone down that hover effect on the actual graph. Because that is ugly, let me tell you. We want to go and set some plot hover slate 700. I don't really like. What if I make it darker? That looks terrible. I don't really like a hover effect on the actual graph itself. Ooh, what happened here? I think I'm gonna take the hover effect on the graph itself off, but I'm gonna leave that hover
Says
effect.
maybe don't change color. Instead change shadow size for the chart. It'll give it a moving effect.
Yeah, if I did that, I need to add that to every single other shadow as well, so I'm kind of not doing that at the moment. So if I do that to one element, I'm going to want that hover effect on every element that does have that shadow, because the shadow is consistent across every element. So I do want to increase the size of this. What's 0.6 look like? Wait, 5?
Myrtle says, ah, gotcha.
Now I could create like a custom CSS class, styling class, and apply it to all of them as like my own hover shadow. So that's probably what I'll end up doing once I like, but I'd have to go back through and make sure it's applied to them.
Try changing the transparency a little bit on hover.
Yeah, we could do that at least, right? So let's see here. Let's do, well, let's just see what we can do. Let's try. So let's go here. Let's do a hover. Well, let's try it. Whatever. Hover. Let's take this shadow, right? And then let's increase this to like 0.8. So now that shadow kind of increases in kind of darkness. And then let's increase the spread. Is it this? What is this color?
Says, "'Cause right now it looks static. I thought the rest of the site is having some engagement with the user." Myrtle says some dynamics.
Oh, this is the spread. So let's just increase this by a factor of 2 all the way around, or yeah, or not a factor of 2, but it's a. There you go. And I get that.
Myrtle says no, the shadow opacity.
We already doing that. We're doing that as well, dude.
Myrtle says BG color.
Let's do 8, 8, 12. Okay, now it has a little bit more responsibility. Like that. That looks pretty good. It's hard for you guys to see because it's on the wrong. Here, I'm gonna. It's hard for you guys to see. Okay, so then let's do. Rather than having a bit too much green, let's leave this at 10. Oh, let's put this at 6. 6. Okay, yeah. So then I'll take this shadow and hover shadow. I'm gonna copy it. And I basically gotta find everywhere.
Says, you know, yesterday I visited your portfolio website and noticed that your website was overscaled. I mean, its size looked normal when I zoomed out to 50%.
Looks pretty good for me. Looks pretty good to me, 100%. I don't know what you're talking about, dude. Sorry, man. Got like an Android.
Says, how big is your screen anyways?
It fits on all of these guys.
Myrtle says, cause when I opened it, it had the Android. Nug says, lol. Myrtle says size I mean.
Sorry, dude. Survey says. Android.
Nug says looks fine.
Yeah. Oh, here you go. Android, I guess it does have a little bit of scaling on the community. On that page. For an Android.
Myrtle says, maybe my device size is small lol.
I think it's just the specific Android. Is it on that community page? Interesting. Every other device, so there is a little bit of a. Okay, so when I get to here, there is a styling wrong with that page. Okay. And potentially this home one as well. All right, we'll have to check that out. All right, cool. So now we have this shadow effect kind of. Let me go here. Let me take my shadow effect and I'm gonna paste it into the orb here. I'm gonna say smooth this effect, but still make it normal or normal looking. Transition shadow. Oh wow. 8 pixels 0.812. So you can add a transition shadow and a duration, basically. Transition shadow and duration. Ooh, smooth. I'll ask. Cause it's a little bit too dark, like, or a little bit like. What if I made the color be a little bit brighter? What if I put like 100 here? Red. 10. Zero, 0.7. So if you want, you can make it, you can apply it. Shadow color. Recommends like a 6612. Ease in and out. So it's wanted me to apply all of these things. So hover shadow, transition shadow, duration 300, ease in and out. That looks awful. That looks terrible. Let's go back to my thing here. Transition shadow.
Myrtle says, all right, buddy. I love chatting with you on your live stream.
Yeah, dude, it's awesome. Same.
I've my phase 2 final exams coming up, so GTG study. It's 10:50 a.m. here. Just saying. See you tomorrow.
Oh, see you, dude. Yeah, it's 10:25 p.m. for me. So, yeah, man, we are on 12 hours apart, completely different times here. I appreciate you for coming in. All right, thank you so much. It's great to meet you and talk to you today. Have a great one, man. Okay, so let's do. I'm gonna lessen the growth on this by a little bit less. No, I'm gonna keep the growth the size, but I'm gonna lessen the transition to just 0.6. There we go. And then I'll put ease in out. Okay, so now what I'll do is I'll copy this shadow. And where am I applying a shadow to? I'm applying a shadow to my box here. Table here. Here is the shadow, so I'm gonna override that. Now, okay, now that, cool. And then on these buttons as well, I'm gonna override the shadow. Okay, on these buttons then, so we'll go here, compound buttons, here. I'll take this shadow, there. Duration. And I'm gonna lessen this. Oh, why is it that much? It's that much? 444, 448, 8812. No way. Six, 10. .7. Okay, so now I'll take shadow here, here, there. I'll go to the search button, shadow, six, 10, 0.7, and then this button over here, shadow, oh well. This is shadow 448 0.5. Compound search, plot generation button. 448 0.7, 448 0.7. So I'm gonna go back to 0.5, which is what I'm doing before, which matches to 0.5448, and it goes to 0.7, 44805. Okay, that's 6610. Okay, so these guys will have some hover effects to their shadows, but the search buttons, I'm not gonna mess with the hover effects to the shadows because I'm having some internal color changes happen. Nice. All right, this is a huge point in our project, you guys, is we have successfully gotten our, let's go ahead and just do some more, just last final adjustments to this guy here. We want to make that bigger. So our left section, we have here. Comp name here, text 2XL. If I say here 400 pixels, 40 pixels, 20 pixels, 30 pixels. So do we even need this generate plot button? Because it's auto-generating, right? Might not even really need this. So aspirin search, there we go, we get aspirin. So the only reason I was using that, generate plot button was to potentially just render out this part, and then you can press generate and then you'll render out the plot, right? So how do you guys think about that? It looks clean though with that button. Generate absorption. Okay. All right, tomorrow we'll link this button to rendering out this, but I think this looks really good for the styling for tonight. What do you guys think? I think this looks awesome. This looks so good. Ah. This data not found. Caffeine. Successful. Let's try a couple more compounds here. Aniline. No. Phenol. No. So we might need to improve a little bit on our...
Solid progress made.
There we go. We got naphthalene. Anthracene. No UV data. Quinoline. Hey, quinoline's there. Quinoline's a strong acid. Salts can cause cancer, according to an independent committee of scientific and health experts. Woo! This looks awesome, dude. Let's do a couple more.
Nud says, did you ever confirm that the two epsilon values were actually different?
Well, the epsilon... Oh, no, not in terms of... well, they are different, but it's really, like, small. Like, in terms of, I think it's rounding, like, by the way of float. So, like, it's multiplying for the Beer's law. It's using those... It's using the epsilon values and then multiplying it by a factor of 1 for distance between the light and the source. So, for 1 centimeter. And then for the concentration is like 1 to the times 10 to the negative like 5. So that's 0.00001, right? So it's such a small factor down that I really don't think it made much of a difference. So that's why it had that linear look. Here, let's ask the orb about it. Let's go over to my compound class. Let's take these and let's say let's go here and say this. When I was generate plots, I accidentally
Nud says, is it normal for those values to be so close though?
well, if you're in Beer's law, I mean, I'm just using Beer's law's equation, right? Which is just epsilon times length times the concentration. So if both of these, if this is a 1 and this is a really small value, then, well, hold on. If epsilon is like 10, should make it really large, right? Or should make it really small. So let's look here. I plotted the generated epsilons as the x values, and this
Nud says you use one array as input for the next grid?
yes, I would definitely explain the linear looking plot. Epsilon equals to this. This is a Gaussian distribution, a bell curve, where wavelength is the x-axis variable, usually in nanometers. Epsilon is the y-axis, the molar absorbability at that wavelength. So plot equals x wavelengths, y generated epsilons. Gives you a nice absorption spectrum shape. What went wrong? You accidentally flipped it. No, I plotted the generated epsilons against the plotting extra. The absorbance curve looks like a Gaussian only when plotted against wavelengths because epsilon itself is a Gaussian function of lambda. So well, let's see, right to be thinking critical. Let's dive into more. Let's assume your concentration and path are both small. Absorbance equals E times 1 times 0.001, which is 0.001 times E. Just scaled down. If your E ranges from values of 0 to 20,000, absorbance is just a factor down epsilon. So plotting E versus absorbance, right? So now plotting epsilon versus absorbance gives us x equals to these x values for the, which is a straight line, even the slope is very small. So like, so I'll take this, I'll say, for example, my aspirin has identical values for generated EPS and absorption. Even though the extinction coefficient, epsilon, and Gaussian distribution can produce large peak values, the concentration has a direct linear scaling effect on the Y values in the Beer's-Lambert law, where absorption at some wavelength equals to epsilon at that wavelength times some concentration times the length of the light source. If your concentration is small, let's say C equals 1 times 10 to the negative 6, then it significantly scales down the absorbance in your data. You have epsilon max is 1200. C is 1, assuming you meant 1 or smaller, and then this is, or similar. Oh. That's why. That's why, right there. Our concentration is 1. Wait, I see my error. I have a hard code concentration of 1.0 instead of like 1e negative 5. So it's epsilon at some lambda times 1 times 1. So the graph is linear on epsilon at lambda. Using Beer's-Lambert, which you hard-coded a concentration of 1 and a path length of 1, then your absorbance plot becomes absorbance equals to epsilon. Such a goofball. Okay, so that's exactly why, Nugs. So let's go ahead and instead go back into our main program, our backend here. And then let's give...
I didn't see the actual method, so I was just completely confused, but that makes sense.
Yeah, so Beer's law, I'll just pull up a quick whiteboard. So Beer's law is just the epsilon at some lambda, at some lambda time. So the absorbance at some wave. So all this lambda means is some wavelength. So the absorbance at some wavelength is equal to that epsilon factor at that wavelength. We're using this epsilon so we can um, have that kind of that scaled factor of Gaussian distribution times the length of the light source. So this is 1 centimeter.
Even if that value was different, it still would have been a linear slope.
Well, no, if this value is really, really small, right, this would significantly scale it down. So yeah, it would still have a linear kind of a proportional relationship with A and E, with just a small factor of scale downwards in terms of magnitude. Yeah, exactly. Yeah. So even if this value is like 1e to the negative 5 for the concentration, right? This is concentration.
Anand
right?
says those are some very long words you just used there.
So let's make this, I'm going to say this, I'm going to give it this. So here is the code. See, it's 1.0 on the class generation. The constant giving you absorbance output that's equal to epsilon, as you already noticed. Replace the line with this, and we'll get a dynamic concentration. If you also expose this to users at front end. So having a smaller concentration just scales down the linear relationship, but it is still linear or very close to B. Exactly. The Beer-Lambert law says that absorbance of wavelength, the shape of the curve is always determined by the Gaussian bell curve. Changing concentration or path length just scales the magnitude height of the absorbance curve down linearly. Okay, so then let's go ahead and do. Also, I don't need to include this generated epsilons. I just need the wavelength and the absorption, right? So then what we'll go ahead and do is we'll go into here, we'll factor into here 1e to the negative 5 for the concentration of the compound, and then we'll generate the Gaussian distributions. We'll generate these, we'll concatenate them together, and then we'll go delete compound predict generated epsilons. We don't need it. So then let's delete this. Let's go back into here. Let's refresh this. Let's go aspirin, search. We got it. And then let's go into here. And there, yeah, see now those are factored down. So before, if you remember, it was 7.622 times 10 to the e the negative 39. Now these are factored down according to that concentration given. So I might also put these wavelengths on the hard code these wavelengths onto the front end, so I don't have to include them in the back end because these wavelengths will not change. Right? Because on our front end right now, our plot is using the y data here, or x data, which is wavelengths given in props, which is here, comp x data, and comp x data is here as wavelengths. So I might code this list
Null
on the
says,
front
or you
end.
could just generate them on the fly in your code. No?
Yeah, that too, right? We could just generate, we could just set this here to that, we could generate it right here, literally right here. So rather than setting it in as,
John
right?
says instead of NA everywhere, it might look cleaner to conditionally render the graph and
Yeah.
description sections.
Yeah, so that's what we're going to do next is tomorrow is we're going to get conditional rendering on the graph and stuff. So right now, so the only thing that'll be is just this, and then when you get a successful search, it'll render out this left side, and then when you press the generate absorption button, it'll render out this right side. So there'll be kind of like a flow to it. So you'll generate a compound, it'll show you this highlighted section, then you can press this button to generate this section. But yeah, we got it linked up though, so it's showing us stuff, which is really awesome. Woohoo! All right. But yeah, we don't need to include these wavelengths in our cache because these don't change, at least for the cache instance of AbsorbSim. So we
John says, oh nice.
right, so we can put these on the front end and have them be rendered when we generate plot, rather than having just raw data just continually pile up, you know, hundreds of lines for each compound, because that's what it's currently doing. We need the X data, or the Y data, I'm sorry, but the X data is just constant across these wavelengths. All right, we got a lot of progress done today, you guys. If you guys are here, please leave a sub. I really appreciate you guys being here and joining me. I'm gonna head out here, you guys. Thanks so much for being here. Today was awesome. I streamed for 3 hours and 35 minutes. Oh my goodness. Long stream today, but we got a lot of work done. We were really vibing and flowing along here, which is super awesome. We were successfully able to generate and link together our front end and back end by getting some compounds. We can do benzoic acid here, and we get benzoic acid. We get the description that we parsed. We fill out all the information from that compound object that we created, and then we are all rendering plots with Plotly. Yeah, so my goal, I would like to, it's gonna be a lot of work, but I would like to also write more parsing scripts, right? Because the yeah, we're gonna do some. We have to get a community project going after this one for the Wackathon. But
Anand says being unemployed sucks.
I was going. What was I gonna say? Oh, so what my goal was to kind of a goal eventually I would like to have is to write a couple different parsing scripts over that JSON object, because the database does include some additional UV spectroscopy information for some different solvents, like an alcohol or you know, there's different types of, you know, they provide you more data. So we could populate, you know, let's say we found 3 or 4 for that compound. Well, we could populate additional rows here and then have the generate button be associated with the row itself as a column. So then you could press the button to generate that specific absorption data like category, right? So we could find, you know, additional sources, have like 4 or so options that the user can choose from, and then have buttons. Boom, you could click that one and populate that graph. Boom, click that one, populate that graph. Boom, click that one, populate, you know? I think that would be cool too. But we'd have to do another parsing thing, and you guys know how that is. All right, cool. So we have success status indicators. We have links out to the actual API itself. We have population of, like, you know, of the information from the database and from the search right here. Cool, benzene. And then we have the absorption spectroscopy being plotted and generated off of those graph values, which is really, really cool too. So this got factored way down because this one's really small, this epsilon. So if I made this, if I say aspirin, this one, this epsilon, so these are factored, these are a little bit bigger. Yeah, so these factor down these Y values by quite heavily having a concentration that small, right? Having a concentration this small really drastically reduces those Y values. So let's like make this maybe -3 then, and let's delete this so we can regen our stuff. And let's get aspirin back here. Okay, so then that takes us to a little bit over 1.2. Yeah, that's a little bit better of a concentration. So now we get a little bit better visuals on our y-axis. We're not scaled down as far. Yeah, there we go. That looks better. So we're also going to add a section below here where the user can generate their own custom plots. So right, rather than just generating stuff from the database, they can have a section to enter their own compound name, lambda, epsilon, concentration, distance. They can edit all those individual variables and then actually generate custom plots with all of those individual parameters custom tailored to their needs. So they can not only generate plots from known compounds with PubChem's database, but generate plots hopefully with their own data, just by filling in the blanks basically for their lambda, their epsilon, their concentration, their light source distance, all that kind of stuff. But this looks really, really good so far. This is definitely our best project we've ever built. It's really coming along. It looks really clean and professional. I'm super proud of this one and happy with what we got so far. We just kind of need to polish up a little bit more styling, make these a little bit bigger, make the spacing a little bit more spaced on between these, and I think here maybe a little bit more spacing, maybe a little bit more spacing right here. Obviously I'm gonna make this a little bit bigger, and then we need to make our logo for the AbsorbSim module of this SpectroSim project. So I'm gonna make a little kind of logo and have AbsorbSim at the top here, and then you have the compound search. So it'll be kind of cool. Well, it wouldn't be like manually adding compounds to the database because it doesn't have any validity to it. So I wouldn't want to actually add it to my cache because this would just be for fun, for dummy. Like if I want to make compound XYZ with a concentration of 1,000, with the epsilon of 1 million, with the lambda max of -2, like what would that look like? And so then it would just show me using my math, right? But then it wouldn't save anywhere. You could save the plot yourself if you wanted to, but it wouldn't like save into the database. It's just for fun. Mahan, we stream every single day. I give my learning, and everything I do is completely transparent. So, but I've been considering maybe opening up this project up to you guys to help me work on, but I've been kind of cooking on it lately, so I've been wanting to keep going. And I really, like I said, I think that this project will be a great opportunity for us to really showcase our skills to employers, to tech companies, to biotech companies as a dev. Like this is a really good project in my opinion. Now I don't know too much, right? But in my opinion, from what I've seen about people trying to get junior dev roles or internships or whatnot, something like this, I think really could go a long way for me. And so, yeah. Let me know what you guys think along those lines. We're finishing the stream off at 2282. Thank you guys so much for following along and subbing. We're 18 subs away from 2300. So hopefully we'll hit that before this weekend. Anyways, guys, I appreciate you guys being here and hanging out with me. It's 11 p.m. Big, nice coding session today. We're making some good progress. I mean, honestly, maybe like 2 more weeks and we'll be done with the project, at least for like a good working version of 1.0 with all the features we want. Obviously, we have to work on the home and the about page, but those will be pretty simple. this is kind of the meat of it here. And then we can obviously add more simulators to this. Like we can go and do some more research about different types of spectroscopy besides absorption and generate new simulations based off of that. So, which is really cool. So you guys can make sure to join my Discord. I wanted to show you guys, link down below, where you can get access to all my resources from Python books, CS50 courses, version control books, calculus math courses that we're taking right now live on the stream, project showcases from the community members, my failed stock picks. We're currently waiting. We need Apple to push up to I need Apple to push up to like 205 by the end of this week. 205 on Apple by the end of this week, 210 by the end of next week, and then I'm cashing. So I post some of my stock plays that I like to do in there that I think might be for fun. It's all for fun though. Anyways, you guys, we need the whackathon mic, don't you? The whackathon. What do you mean? How's the whackathon gonna ruin your career? Not how's the lack of whackathon gonna ruin your career? What do you mean? How does that work? How does that work, Mahan? All right, I'm gonna take a screenshot of this. I'm gonna paste this into the Discord here. Oh. That looks really good. That looks so freaking good. Woo! So if I say test here, oh, this generated an absorption though. What? NA is, but this, oh, does it just keep it the old one? So this is right here. Okay, let's see if this doesn't change at all. Okay, it just keeps the old plot. Okay. All right, this looks really awesome. I'm super, super happy with it. Let's push this up. GitHub's been really annoying lately. It's been, I think it's because it's like in between time zones, but where its servers are or something. And so when I push late at night, but I'm still in my current day, June 2nd, it counts as a missing entry for June 2nd, but will hit for June 3rd. So I don't know. It says I missed some days, but I did not miss days, let me tell you. Add plot generation, add backend, Gaussian and absorption data generation on compound object on searched compound object. We'll say add populate data into Plotly JS plot styling. This is a bad commit message. There we go. So now if we go check out our GitHub, that should be up there. Let's just double check. 15 seconds ago. Good. Add backend support. Yeah, see, it says look at this. I code it every single day, and it's like giving me this huge gap lately. So if I don't commit by like, I think like 9 p.m. my time, I lose that day. So it's really annoying. But then it counts for the next day. But it's weird. I committed all of these days. Like I really don't get it. It's not a big deal. I mean, it's just a graph, but like June 1st, I committed. I should have a bunch more greens here, and visually it'd look a lot better. Go to setting in my time zone. I got my Bay Area here. My area. Save trending settings, job, update preferences. Security? No. Okay, I just updated to include my time zone on my profile so you can see my time zone now. 2308. Right, now you can see my time zone here. Can I make it not 24 hour? Settings. Profile. Public profile. Does it have to be specific? Yeah, it does. Whatever. Contribution does not equal commit. So then what is let's look. Contribution major repositories. Coordinated universal time code rather than your local time code. To coordinated universal time code rather than contribution only counted, they meet a certain criteria. In some cases, you may rebuild your graph. If you're a part of a contribution that activity, issues, pull requests, get elements, the number of these items, commits, gives them appear in the graph as they meet the following conditions. Email address is used. So it's this. This is what's screwing me here. Coordinated universal time. So if I hit past probably 9 p.m. my time, 12 p.m. Eastern, then if I don't commit by then, I miss the day. Hey, Mahat, how's it going? Welcome back in, dude. Mahat Patel, it's been a while, dude. All right, you guys, I'm heading out. It's been an awesome stream. 3 hours and 52 minutes today. Big stream. We got a lot of features done. We built some really cool stuff today on our project, SpectroSim. We actually linked the graph for generating compounds like aspirin from our database, pulling API and requests from PubChem, so we can generate plots with aspirin. We can do like caffeine. There's caffeine, yada yada yada. So it's really nice. Maybe I want to update the status when we search, when it's pending, it'll say like searching, and then when it's success, it does success. So I'll make that so when it goes, when it's awaiting the response, it'll update this to say searching, and then when you get the response, it'll say success. Right now it just says success no matter what, or a fail. So if I say aspirin, right, there's no kind of, and it's really fast because it's on my end, it's really fast, but when it's on the server and stuff, that'll kick in. All right, you guys. See you guys tomorrow. I'll be back tomorrow, 7 p.m. PST, to continue on with this full stack project. Yes, we're building full stack. It's really awesome. We're populating our information from our database, our scraping. We are plotting curves here, which is really cool. So which is really, really awesome. Thank you guys so much for being here, and I'll see you guys tomorrow. Have a great night. See you guys.